Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
Hello, my friend. Welcome back to Web Accessibility for All, the podcast where we discuss how to make the web more inclusive and accessible. I am Ariel, your host, and today we are kicking off a two-part series on creating accessible wizard experiences in React. Yes, wizards, those step-by-step processes you've seen for everything, from booking travel to personalizing your pizza. Spoiler alert, that's today's theme. While these wizards are helpful for many, they can pose challenges for people with disabilities, especially those relying on screen readers or keyboard navigation. In this episode, we'll build the foundation for an accessible wizard using React.js, modern design patterns, and ARIA roles. Ready? Let's dive in.
What is a wizard for, and why accessibility matters?
A wizard breaks a complex task into manageable steps. For example, designing your dream pizza in 3 steps. Crossed selection, toppings, and reviewing your choices before submitting. Sounds simple, right? But for users navigating with assistive tech, simple can quickly become a nightmare if we don't follow accessibility best practices. That's why we'll use ARIA patterns to clearly define progress, structure, and navigation. Accessibility isn't an afterthought here. It's the core of our design.
What's our goal today?
Our goal for this episode is to focus on laying the foundation. Think of this as building the skeleton of a house. We'll add the details like validation and focus management in the next episode. Today we'll cover 1. The high-level structure of the app. 2. Component separation for scalability. 3. Basic accessibility considerations.
App overview.
Our pizza wizard is a step-by-step form where users can make choices to customize their perfect pizza. It's built with React, so we'll break our app into reusable components. We'll also use a basic design pattern called composition, where smaller components come together to form the larger app.
Component breakdown.
Cool, let's get started with the code. We'll have a main component to control everything, then smaller ones for each step of our wizard, plus a few more to finish off the interface.
Wait, Ariel, there will be so many components. That sounds like a lot of work.
Yeah, I know, but trust me, it's the best way to keep things organized. We'll give each component a specific job, and that will make our code much easier to understand, test, and refactor if necessary. Sounds good?
All right, let's do it.
Pizza Wizard component.
This is our parent component. It holds the state and coordinates what's displayed in the UI. Think of it as the wizard's brain, managing which step is active and passing props to child components. Now let's check its code and then review what it's supposed to do, okay?
Const pizza wizard equals greater. Const current step, set current step equals use state, 1. Const form data, set form data equals use state, size, toppings. Blank. Const handle next equals greater set current step plus 1. Blank. Const handle back equals greater set current step 1. Blank. Return. Less div. Class name equals pizza wizard greater. Blank. Less div. Class name equals pizza header greater. Less h1 greater. Design your dream pizza. Less /h1 greater. Less img. src equals ./pizza.jpg. Alt equals a delicious pizza illustration /greater. Less /div greater. Blank. Less step indicator. Current step equals current step. Total steps equals 3/greater. Blank. Less step. Is visible equals current step equals 1. Legend equals choose your pizza size greater. Less h2 greater step 1, choose pizza size less /h2 greater. Less step 1 content. Form data equals form data /greater. Less /step greater. Blank. Less step. Is visible equals current step equals 2. Legend equals select your toppings greater. Less h2 greater step 2, choose toppings less /h2 greater. Less step 2 content. Form data equals form data /greater. Less /step greater. Blank. Less step. Is visible equals current step equals 3. Legend equals review your pizza greater. Less h2 greater step 3, review and submit less /h2 greater. Less step 3 content. Form data equals form data /greater. Less /step greater. Blank. Less div. Class name equals navigation buttons greater. Blank. Less button. Type equals button. On click equals handle back greater. Back. Less /button greater. Blank. Less button. Type equals button. On click equals handle next greater. Next. Less /button greater. Blank. Current step equals 3 and end. Less button. Type equals submit greater. Submit. Less /button greater. Less /div greater. Less /div greater.
Alright, that was a big chunk of code, wasn't it? Let's explore what we have done here. This component implements a multi-step form. It guides users through 3 steps to build your dream pizza, one step at a time. Step 1, choose the pizza size. Step 2, select toppings. Step 3, review and submit. As the primary component, it will house most of the complex logic, while its children should remain relatively simple.
State management.
Current step.
Tracks which step the user is on. Step 1, Step 2 or Step 3.
Form data.
Stores the user selections.
Step-by-step content.
Each step is encapsulated in a step component, which includes the header and specific content. Steps have their own components. Step 1 content, Step 2 content, and Step 3 content to handle user input.
Navigation buttons.
Buttons allow users to navigate back and forth between steps. On the final step, a submit button appears for submission.
Visual elements.
A main header with a pizza illustration welcomes users. A step indicator visually shows the user's progress through the 3 steps. In short, this component provides a user-friendly and accessible experience for creating a custom pizza by dividing the process in manageable steps. The main objective of a wizard or a multi-part form pattern. Now let's continue with its child components.
Isn't it overkill to use separate components? Couldn't you just throw everything into one component and call it a day?
Sure, if you love debugging spaghetti code. Let's keep it modular, okay?
Step indicator component.
The step indicator visually represents the user's progress through the wizard. It visually and programmatically indicates the current step, accommodating varying numbers of steps.
Const step indicator equals current step, total steps, equals greater. Less div. Class name equals step indicator. ARIA label equals step $current step of $total steps greater. Array.from, length, total steps, I, equals greater. Less div. Key equals I. Class name equals step item $I plus 1 equals current step current. Role equals status. ARIA current equals I plus 1 equals current step undefined greater. Step I plus 1. Less / div greater. Less / div greater.
This component receives 2 props.
Current step
Specifies which step the user is currently on, and
total steps
indicates the total number of steps in the process. We put strong focus on accessibility here. The container has an ARIA label that announces the user's progress in a screen reader friendly format. Also, each step element includes
role status
for conveying dynamic progress, and an
ARIA current step
attribute if it represents the current step, helping screen readers identify it as active.
Step component.
The step component serves as a container for each step's content. It uses a semantic field set to group related form elements.
Const step equals is visible, legend, children, equals greater. If is visible equals false. Return null. Return less field set. Class name equals step greater. Less legend greater. Legend. Less / legend greater. Children. Less / field set greater.
Pretty simple, huh? Yes, the single responsibility of this component is to display specific step content only when it's supposed to be visible. It receives 3 props.
Is visible.
This tells the component whether it should show the step.
Legend.
A short title for the field set's legend, telling what the current step is required for.
Children.
The actual content for the step that gets displayed when the step is visible. So basically, if the is visible prop is true, the step's content is wrapped inside the field set element, which groups the form-related content together.
Do we really need field set and legend? Nobody uses those.
Well, some people never floss, but that doesn't make it a good idea. Proper semantics make forms easier to navigate for everyone.
Step 1 content component.
This is the first step where the user chooses the pizza size.
Const step 1 content equals form data, update form data, equals greater. Const sizes equals small, medium, large. Blank. Return. Less greater. Sizes.map, size, equals greater. Less label. Key equals size greater. Less input. Type equals radio. Name equals size. Value equals size. Checked equals form data dot size equals size. On change equals e equals greater update form data size e dot target dot value slash greater size less slash label greater less slash greater.
This component is all about letting the user pick a pixel size, small, medium, and large, ensuring a semantic structure and an accessible experience. For this episode, we'll focus on the first step. The remaining two steps are similar in concept, so we won't go into detail to keep things concise. You can find all the code on GitHub. The link is in the episode description. Feel free to fork and experiment. And that's it for today. We built the structure of our accessible pizza wizard using composition and ARIA patterns to create a solid foundation. Don't forget to check the GitHub repo for today's code. In the next episode, we'll tackle focus management, validation, and styling to bring this wizard to life, and we'll ensure a smooth and inclusive experience for everyone. Happy coding and happy pizza dreaming. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.